Hello friend, I am Naval. You are watching Code with Naval. Welcome to Java series part 97. In the last video we saw tree map. In this video we are going to discuss about map synchronize, or you can say thread safety. In a map have a three synchronized classes. First one is a hash table. Let's discuss one by one. First one is a hash table. This hash table apply a lock at a method level. Then we have a second synchronized map. This one is a method. This method is present inside a collections class. This method simply here we pass a object map object, and in return we get a synchronized object. Okay, here apply a lock at a object level. Then third one we have a concurrent hash map. By using a concurrent hash map we can apply a lock at a block level or a bucket level. This concurrent hash map don't allow any null key or null value. Okay, here we have a three option: hash table. By using a hash table, synchronize map, and third one is a concurrent hash map. There is the only difference. Hash table is already legacy class, that's why we don't use a hash table mostly. Then second we have a synchronized map. This synchronized map directly applying a lock at a object level, that's why here performance issue in a synchronized map. Then we have a concurrent hash map. This concurrent hash map apply a lock only particular code, only particular block level, that's why here we don't get any performance issue. Okay, let's see practically one by one. Okay, I'll simply open this Eclipse and I'll create here one class and give this class name is a part 97, and here we create a main method inside this class. Let's create main method, and first we check what inside a hash table. Okay, let's create a hash table. You can see here hash table. Let's open this declaration hash table. Here you can see this hash table introduced in a Java 1.0. That's why this hash table is a legacy class. And you can see this hash table have a several methods. If we open any method, okay, let's open this size method. You can see this size method is a synchronized. That means this method is a thread safety. Then you can see this is empty. Here also applied here apply a synchronized keyword at the method level. That means here we apply a lock at a method level, not in a object level. Okay, here by using this synchronized keyword we can make this method thread safe, and this hash table is a synchronized class. Okay, then we have a synchronized map. By using a synchronized map you can create any other already created object we can convert in a thread safety. Okay, let's create. How can we do that? I'll simply create a hash map. Okay, let's create a simple hash map object, and you can create a generic. This time we will create a non-generic only shm. Let's create a hm equal to new hash map. Let's create here new hash map. Now this hash map is not thread safe. Now I want to create this hm object thread safe. How can we do that? We can simply use a collections class. Okay, collection is an interface and collections is a utility classes. Collections dot synchronize. You can see here we have a method synchronize list. We can convert a list also in a synchronize. Then we have a map, then we have a set. Okay, let's use this synchronize map, and here we pass a hm. This synchronize map method return a thread safe object. Let's store that object in a new reference variable, or we can say new variable. Okay, I'll simply create here new variable hms, and here we need to typecast this synchronize to hash map. Okay, so here you can see here we get the option add casting, and here we simply typecast this return object, this return thread safe object. This hms is a thread safe and this hm is a not thread safe. Okay, in this simple way we can create any map object in a thread safe object. Okay, so but here we got some issue, performance issue, because this HMS apply a lock at a object level, and if applying a lock at a object level, then one time only one lock can access, only one thread can access that object. Okay, then finally we have this concurrent hash map. This concurrent hash map apply a lock at a bucket level or a block level, and this concurrent hash map don't allow any null key or null value. Okay, let's create here concurrent hash map object, concurrent hash map, and let's see what inside this concurrent hash map. Okay, let's open this declaration, and here you can see if I search here. Okay, let's search here synchronize, and here you can see here applied synchronize, here applied synchronize, or we can say thread safety at a block level, not at a method level or a class level. Okay, let's see again. Here you can see here also applied at a block level, and if I search again, here you can see here also applied at a block level. That means this concurrent hash map only making thread safe code that actual need. Okay, only making a particular code thread safe, not making a whole method thread safe. If we create a whole method, then lock applied at a method level, but here lock applied at a bucket level. Okay, that's why here we get a better performance, better than this synchronized map. Okay, let's create here. Okay, I'll simply create here one object ch. Okay, ch equal to new concurrent hash map. Let's create here concurrent hash map and remove this, because here we are creating a non-generic sh dot put null. This concurrent hash map don't allow any null key or value. Let's try. I'll simply insert a null key and null value, and let's try to print this system.out.println sh. Save this, run this. Here we get an error. Let's see what error here we get. Hash map until cannot cast. Okay, here typecasting error. Okay, let's instead of hash map, let's put here map, and here also map. Okay, let's save this and run this. Let's check. Okay, this one is the result. Okay, this one is the result now. Okay, let's see what error here we getting. Let's add here and remove this key value map. Now let's check again. Here you can see now here we are getting a null pointer exception. This error is a line number 18, and you can see here in a line number 18 here we added a null key and null value. Okay, now let's add here valid key and null value. Then again try. Again here we get a same error, null pointer exception. If we add null valid value, here you can see here we add one key and one value, and let's run now and let's check. Here you can see here we get a actual value. Now this concurrent hash map don't allow any null key and null value. Okay, let's see how many constructor provide this concurrent hash map. And here you can see this default constructor. Then here initial capacity, here we can pass a initial capacity. Then here we can pass any other map object. Then here initial capacity and load factor. Then here finally initial capacity, load factor and concurrency level. Okay, if your requirement is a thread safety, then you can use this concurrent hash map, but you have to remember this concurrent hash map don't allow any null key or null value. Okay, this one is also good, but here we have a one issue. This one is a apply a lock at a object level. That's why here we get a performance issue. Okay, and this concurrent hash map apply a lock at a bucket level or a block level. That's why here we get a good performance. Okay, in this video that's it. We will see next topic in the next video. Till that, bye bye.